Hey, welcome. This lesson is going to be on Newton's second law of motion. And many of you researched this already and have found out what it is. And we're just going to go over it briefly here. I don't have any formal notes for this. This is just going to be a brief introduction. We'll go into more detail later. You can take notes on a separate piece of paper if you'd like to. Okay, so Newton's second law can be formally stated as F net is equal to mass times acceleration, where acceleration is in meters per second squared, mass is always in kilograms, and F net is in newtons. Another way to state this is by saying acceleration is equal to F net divided by mass. Okay, so basically what this equation shows is that the acceleration of an object depends on the force and the mass on the object. If there's a net force on an object, it's going to accelerate in the direction of the net force. And the greater the net force, the greater the acceleration. It's pretty simple. And the mass, if the mass is increased, the acceleration decreases. So it's directly proportional to force, which means if force increases, so does acceleration. And it's inversely proportional to mass, which means if mass increases, acceleration decreases. So an example could be you are kicking a soccer ball. If you kick with a certain force, while you're kicking, while your foot is in contact with the ball, there's a force, net force, for acting forward on the ball. And so the force causes the ball to accelerate, to move in the direction of the force. It speeds up. Once it leaves the foot, there's no more force, as we saw in Newton's first law, and then it just keeps moving at constant speed. If we double the force, then we also double the acceleration. So that's basically Newton's first law, or second law, sorry. Okay, now we'll take a look at a couple of example problems. So let's draw a free body diagram. Let's suppose you have a block with a mass of 5 kilograms and you apply a force of 10 newtons to it. It's going to accelerate in the direction of the force. We can calculate the acceleration, which equals F net divided by mass, and that's equal to 10 newtons divided by 5 kilograms, which equals 2 meters per second squared. Okay, so you can copy that down if you'd like to. If we keep the force the same, but we double the mass, so we make the mass 10 kilograms, and the force stays the same, you can see that the acceleration is going to decrease. So acceleration equals force divided by mass. So in this case, this is now going to be 1 meter per second squared. So when we double the mass, we half the acceleration. Acceleration becomes half as much. Now let's take a look at one last example. Let's suppose we have a force acting on a block of 5 kilograms and the force is 10 newtons. But let's suppose now there's a force of friction acting in the opposite direction of 5 newtons. Now remember, this is a key point. It's not the applied force which causes the acceleration, it's the net force which causes the acceleration. So we have to calculate the net force in this case, which is equal to 10 newtons minus 5 newtons divided by 5 kilograms, which equals 1 meter per second squared. Okay, that's it. So to begin with, I'm just going to start off really simple and do a few simple examples, and we'll go into a lot more detail in upcoming lessons. But for now, that's it.